Good morning, everybody, and welcome to today's webinar. Before we begin, I'd like to acknowledge the traditional custodians of the lands we are joining from today. I pay my respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples with us. My name is Chris Davies. I'm a client engagement principal at DiUS, and I'm here to facilitate today's webinar, Applied AI Legacy Modernisation. Or in plain terms, how we can move from legacy technology stacks to something more fit for purpose using generative AI. Now, we speak to CTOs, heads of engineering and the like every day, and the general consensus on using AI to modernize, well, it's extremely interesting, to be honest. In fact, I just wanted to share this insight in particular from James Ross, who is CTO of Seek. Now, he shared this when we recorded him for an upcoming episode of our Tech Trajectory podcast. I suppose now's the time when I should say go and like and subscribe on all your favorite podcast channels. But what James said is that AI would get me excited about legacy modernization again. There's so much legacy code that the world is just looking the other way. AI represents a huge leverage to rewrite a lot of stuff, which would have just been prohibitively expensive to rewrite otherwise. So this is a really, really common thread to a lot of the conversations we're having. Legacy systems often mean tech debt and complexity, and obviously no one really wants to bite that off. There can be sparse or outdated documentation, also a fear of breaking critical services, especially as the people who wrote that code could have been, moved on a long time ago. So you combine all those factors together, and modernization is something that takes months and months, and then it could even pull your best people away from doing work where it's better spent elsewhere. So that's where DiUS believes that AI can really help, whether it's automated assessments to map code bases, transformation and refactoring for faster, safer changes, even fresh documentation for old areas of the system. So a bit about us, if you don't know already. So we're a tech consultancy. We build software with Gen AI every single day. We know where it helps, we know where it hurts, and we also know how to make it stick across teams. So we fully understand and know that AI is not a silver bullet, but we do believe that it can be a genuine accelerator for discovering and assessing legacy systems to then inform modernization. Now, before I introduce our speakers, a bit of housekeeping. So we do have a Q&A section for you to ask questions of our speakers, and we've left plenty of time at the end to address those. And also, depending on how we go, we might even introduce some polls throughout the webinar as well to just get a sense of where you're at on your journey and an appetite for modernization. So moving on to today's speakers, I'm very pleased and privileged to have Oliver Gibbs with us. He's a senior partner solution architect from AWS who has over 2 decades of experience translating tech innovation into measurable business outcomes. Ollie specializes in agentic AI, generative AI, data foundations, cloud security, and thankfully for us, modernization. And we also have Warner Godfrey, who is a principal consultant at DiUS. He has over 20 years of experience in software development. What we love about Warner is he has a tendency to really dig deep in order to solve issues and paint the most comprehensive picture of a problem possible. And that's why a lot of the time he's our go-to guy for things like modernization. So how it's going to work today, first up, Warner's going to walk us through what good looks like when it comes to modernization, especially with AI. And then Ollie will jump into the tools that AWS has available. So Warner, it is over to you.
Thanks. I'm in the same room as Ollie, so we'll coordinate our speakers and our microphones. So our modernisation approach. So we've learned that you can't just embark on a modernisation strategy without truly understanding where you are, what's your current state. So we always recommend starting with a thin vertical slice. And that could be a thin, like a user journey or a critical scenario that tests your architectural decisions with real world feedback. And that gives you the opportunity to refine and commit to the full transformation journey. Now, that's not always possible in that way. Sometimes it's teasing things apart from the edges or replacing one of the subsystems, but doing something that can be deployed into production and understanding how it operates in. So the other thing is, you can't underestimate the operational side of the change. So you can't progress the strategy if you're constantly fighting fires after making a change to production that may impact users or place additional stress on the operational staff. So you need robust change management, monitoring strategies, and the operational readiness. So there's a dilemma with discovery. It costs a lot, so much so that teams can either skip it or trim it down or rush through it and not do it properly. So that's all with good intentions. People just want to get started. But when you skip the in-depth discovery, your unknowns are still unknown. And they don't disappear, they just surface as unplanned work later on in the piece. So I guess we don't want that. We don't want surprises. Surprises can mean that you can't get through the full scope of the project, or you might actually find something that upsets the balance or the return on investment of what you have embarked to achieve. Next slide, thanks, Chris. So the discovering is not just about understanding what exists, it's also equal parts archaeology and forecasting. So you want to understand how you got here and also anticipating what could go wrong in the future. So legacy system discovery is kind of like an archaeological dig. So the things you find are fragmented and fragile, and you've got examples like code that doesn't compile, or dependencies that are been archived or removed from a repository, and then documentation sometimes reads like folklore, so it doesn't necessarily describe what you're experiencing today. And finding really useful artifacts like architectural decision records is about as likely as finding a crate of vintage champagne at the bottom of the ocean. So now we are fortunate that we can find people with living memory. And if you do find someone who's either a system owner or someone who worked on the system, interviewing them is incredibly helpful, and introducing that as an artifact that can be analysed. But their representation is not always the way that things are. They might have a historical view of the system, or might not have context of changes that have happened since then. Okay, next slide, please. Here we have where AI excels and where I guess traditional engineering and architecture might have a place. So AI, it's really good at mapping what exists and surfacing the structure of the system, the dependency maps, and also handling tedious tasks like porting code or updating libraries and frameworks. So, but look, it struggles with the business context side of things. So we really need to be involved to help look at the outputs and keep them aligned to the business strategy. So the other things are there's a lot of domain-specific and business-specific knowledge and ways of operating. So it doesn't have that sense of smell of what problems could actually cause real issues with the business going forward. So this AI in the end gives us the map, but the experience is still used to chart the course. Over to the next one. Thanks. So the pattern we're seeing combines AI accelerated discovery with human-driven architecture. So we let the AI tools do the heavy lifting. That's the system mapping, dependency analysis, and the grunt work of digging through all the artifacts and understanding of what exists and what's available. Then we can take those maps, do things like gap analysis to understand where we are, where we want to be, and actually start to make those architectural decisions. So, for example, where should we make the change? How do we sequence the changes? And also the target state, which caters for the needs right now, and also can flex to meet the strategic objective. So, and then the implementation side, that too. So the code conversion, generation, and the mechanical parts of the transformation. So it's not just doing it in one hit either. It's actually doing this as an incremental cycle. So with the human in the loop as well. So, but then we're looking at the human element, which is really a cross-cutting thing where we're looking at the strategic decisions, we're aligning with the business and managing the change from a change management perspective. So, and they're all the things that actually require human judgment. Okay, so on the next slide. So we've got this division of labour, and it's powerful because it frees up the architects and senior engineers so they're able to focus on the high value work, and which is designing solutions and managing complexity. So, and they can do that rather than or weeks doing manual code archaeology. So I'll hand over to Oliver now, who will talk to us about AWS Transform.
Thanks, Warner. So I'm Oliver Gibbs, a Senior Partner Solution Architect at AWS. I've been with AWS for about 5 years, and I think Chris has covered off my areas of specialization. So let's jump straight into accelerating modernization using agentic AI. In the enterprise landscape today, 70% of workloads remain on-premise. It's common for these workloads to be running business operational code developed more than 2 decades ago. The migration timelines we're seeing in the field demonstrate how resource intensive these transformations have become. Now, these metrics reflect the real challenges faced by enterprise customers who are attempting to modernize their environment. So let's unpack this a little further. In our discussions with customers, we're commonly seeing enterprises face 3 types of challenges in their transformation efforts. Slow transformation speed. So this is where organizations need to accelerate their modernization initiatives while managing limited resources and expertise. And Warner touched on some of these points earlier. Traditional approaches to transformation typically consume more than 18 months of manual effort, requiring extensive time for discovery, planning, and execution. With 70% of Fortune 500 companies still running decades-old software, Businesses require automated solutions that can reduce the time spent on technical debt, dependency mapping, and documentation generation, reducing down from months to days. Limited scalability. Organizations need to transform hundreds of applications simultaneously while maintaining operational consistency. Integration challenges affect 34% of organizations, with 57% struggling to integrate cloud resources with on-premise systems. Teams need a unified approach that enables parallel processing of multiple workloads while coordinating across project managers, architects, developers, security engineers, and of course, business stakeholders. Complexity increases when managing multiple types of transformations, from infrastructure migration to application modernization and ongoing software updates. And AI expertise. So organizations need specialized expertise across multiple domains without expanding headcount or extending project timelines. Nearly a third of organizations cite talent gaps as a key barrier, with specific shortages in cloud management, security, and development skills. Teams need intelligent automation that leverage AI to understand and transform diverse workloads, including VMware, mainframe, and .NET, whilst maintaining security and compliance requirements. It's for these reasons we need to rethink our approach to transformation. So let's now consider how AI is influencing the transformation approach. Large language models, or LLMs, are capable of processing millions of lines of legacy code, understanding the complex business logic in a way that goes beyond rule-based systems that were previously common. Combining with graph neural networks, complex dependencies can be mapped out to create topologies automatically. Now, with these, customers are enabled to run what-if scenarios that previously took weeks to conduct an analysis over. Together, this leads to foundational innovation. Now, with agentic AI automation, systems can reason through complex problems and accelerate business outcomes. And this leads to AWS Transform, AWS's first agentic AI service for large-scale migration and modernization of VMware, mainframe, and .NET workloads. In the interest of time for today, we'll focus on AWS Transform's VMware and .NET capabilities. The service is available via the AWS Management Console for enterprise-scale modernization of .NET, mainframe, and VMware workloads. Or if you're working on .NET application modernization, it's also available as an extension for the Visual Studio IDE. Now, AWS Transform provides an assessment job type that is designed to provide cost estimates and saving analysis for migrating your workloads to AWS. The assessment uses an advanced AI-powered language model, specifically trained for AWS infrastructure analysis. The specialized LLM evaluates Amazon EC2 instance recommendations, performs your bring your own license or BYOL analysis, and determines optimal dedicated host mappings by incorporating real-time Amazon EC2 pricing data and host configuration specifications. The assessment helps by providing 3 key insights to guide your modernization. Bottom left, there's reduced costs. So this is really overcoming the costly on-premise inefficiencies with optimized workloads on AWS. You get detailed financial modeling that uncovers cost-saving opportunities, right-sizing your resources as you migrate to AWS to reduce costs and, of course, lower your total cost of ownership, TCO. At the top, there's simplified planning. So this is where it's removing the guesswork from cloud migration decisions with actionable insights that help guide your migration strategy. This makes informed decisions about your migration path and the expected outcomes. And bottom right is improving efficiency. So this is eliminating weeks of manual data analysis to understand your on-premise infrastructure. Utilize AWS Transform assessments to actually provide immediate visibility into your environment so you can actually streamline and accelerate your cloud migrations. The assessment job type in AWS Transform currently supports compute-based workloads. Whilst it includes servers deployed to run specialized workloads, it cannot access the specialized workloads themselves. And as Warner mentioned earlier, this is where DiUS can add additional value, helping you unpack and prepare your workloads with their extensive application modernization experience. The workflow begins by uploading your existing server inventory to AWS Transform Service. This server inventory can be RV Tools export, can be the Migration Portfolio Assessment, the MPA import file, can be the Migration Evaluator export, or an export for vCenter. To include storage assessment, you can also upload a NetApp Data Infrastructure Insights, or DII file. Once your data is in place, you have the opportunity to specify your target AWS region. Next, you instruct AWS Transform to generate your business case, and AWS Transform analyzes your provided inventory data, identifies the most suitable and cost-effective Amazon EC2 instances for each. The resulting business case provides you with a clear data-driven projection of how your current on-premise environment could map to AWS services, offering valuable insights for your migration planning and decision-making process. Let's now look specifically at AWS Transform for VMware, our agentic AI service for modernizing VMware workloads to cloud-native Amazon EC2. We've seen three main drivers for VMware modernization from customers in the field. Legacy workloads have become an innovation blocker, and customers are finding their VMware environments are holding them back from adopting new technologies and impacting their time to value. Secondly, the recent changes to Broadcom licensing has influenced customers to reevaluate their VMware strategies and investments. And thirdly, customers are also finding their teams are unsure how to bridge the skills and knowledge gaps presented by legacy workloads, creating some friction and delays to any transformation efforts. So let's just look at VMware Migration Agent within AWS Transform. It's a goal-driven autonomous approach whereby long-running agents dive deep to accelerate migrations of virtual machines and networks to Amazon EC2. There's four key phases. Firstly, discovery and data ingestion. This is where discovery agents dive deep into your VMware environments, map out everything from basic inventory to complex dependencies. This phase can save weeks of documentation effort alone. Secondly, wave planning. Here, the agent generates intelligent wave plans, factoring in application dependencies, compute capacities, and business constraints. Next, the network conversion and migration. Here, the VMware environment network configuration is automatically translated into AWS native networking constructs. This provides a significant time-saving benefit for customers. And then lastly, the VMware migration and deployment. Here, the agent orchestrates the actual migration work while upholding the application integrity. Now, the step-by-step transformation keeps the human in the loop at all times for validation. AWS Transform for .NET allows you to offload the tedious manual porting tasks, including the code analysis, the dependency mapping, and refactoring. The result is accelerating the speed of a transformation by up to 4 times. By modernizing operational costs, can actually reduce by 40%. AWS Transform supports the porting of hundreds of .NET applications in parallel using its AI agents. Modernization presents a boost to application security and performance. Now, with every new release of .NET, Microsoft are investing heavily in performance improvements. On Linux, this can realize a 1.5 to 2 times improvement and can contribute to a cost reduction, given the same application can now run in a lower CPU and memory allocation. Porting to cross-platform .NET is often hard and slow when done manually. It's labor-intensive, often error-prone, and often creates collaboration bottlenecks in teams. And Warner really touched on all these points earlier. Today, AWS Transform supports .NET Framework 3.5 onwards, .NET Core 3.1, .NET 5, 6, and 7, all as sources, and .NET 8 as a target. So how does AWS Transform for .NET work? On the left, AWS Transform can be used from the AWS Management Console for large-scale transformations or from its Visual Studio IDE extension for developer-led transformations. The process starts with an analysis where your code base is analyzed to understand any repository dependencies and any code incompatibilities. During this stage, a modernization plan is prepared for review, outlining the immediate steps and tasks required to transform your application to .NET 8.0 onwards. Next, the process enters a transformation stage. This is where the AI agent will leverage large language models to conduct the transformation. This detects and transforms Windows-specific code to Linux-compatible code, porting the .NET framework code to cross-platform .NET. The transform is written to a transformation branch within the code base, so the original code base is never manipulated. Then the code base enters a validation stage, using tests to ensure the buildable code base and Linux-ready application on .NET 8, the latest long-term support version. And at all stages, we have human oversight. None of your code is modified until reviewed and accepted by a human in the loop. This gives you the opportunity to validate the proposed modernization plan, to upload any missing package dependencies that have been identified, or review and accept the transformed code, all for examples. Jumping on to the next slide, Chris. And as mentioned, AWS Transform for .NET is available both in the AWS Management Console, as shown on the left, and the extension for Visual Studio IDE, as shown on the right.